Meteor Impact.
Okay, so hello everyone. Today we are going to talk about the deep dive to Meteor reactivity model. I announced it on the forum as well, and there was soon time after that some posts about, let's say, a similar technical overview of the topic. So I wanted to make it more engaging and slightly more about a slightly broader topic. So the subtitle to it is going to be, and why I think is the DDP router is actually so exciting. If you don't know what DDP router is, don't worry, there will be an introduction, so we can just get started. So 2 words about me. So first of all, I work with Meteor for over 10 years now, which is quite a while. And this is all like part of my work, and I still work with Meteor, so it's not like a thing of the past for me, it's like a day-to-day thing, so I'm still very happy to be here. Then I'm technically a Meteor core committer, so what it means is that I can also review pull requests. I can also help with like reviews and all that stuff. And I'm mostly focused on MongoDB, but also Blaze. I don't know if you are still using it. I guess some people are. There will be a presentation from Jan later about it. But basically, I was the person responsible for making the Blaze support the asynchronous like operations, helpers, all that stuff. And like in my day-to-day work, I'm a head of engineering at Alino. So yeah, that would be like a brief intro about me. If you want to know more, everything is on my website, radek.dev, and basically those slides will be there as well. I'll share the link later on the chat in here, but if you want to get like those slides or maybe slides from the other Meteor conferences or some articles, things like that, you can just go there and take a read. Yeah. So the agenda of today would be that, first of all, we would like to understand what really happens between doing an insert on the client side and then getting the results back in the form of, let's say, fetching the results from the collection. We will skip a lot of technical parts in here, but we just mentioned like the most important pieces in the whole architecture, and most importantly, focus on the differences when we have, for example, redis-oplog in this whole picture. So how and actually why redis-oplog makes the whole application scale better? Like, where's the difference coming from? Why is it actually so helpful, and why are people actually doing it with Meteor? Then how changestream-to-redis, which is a tool I will mention slightly later, also makes it even better, especially with like the recent changes implemented there. And then finally, why I think that the DDP router is so exciting in the future for the Meteor. Okay, so let's start with having the insert on the client and getting the data back. So the default way of working with Meteor and working with the data is the oplog tailing. If you don't know what the oplog is, it's basically a short name for operation log. So it's a list of all of the operations that happen in MongoDB. And what MongoDB gives us is a literal list that somebody made an insert, some update happened, some delete happened, all those sort of like very small pieces of information that some collection received some change, right? That's what we get from the database. And that's basically how Meteor worked forever, like since almost its inception. There was a talk about it on, I think, Meteor Impact in 3 years back. But basically the idea is very simple. So on the client side, we want to somehow communicate with the server, right? We just want to say, okay, I made an insert to the database. Please insert this document to the database. So what the client side does, it cannot connect to the database directly. We don't want that. It's most likely insecure. But what we can do is we execute a method on the server. So like the client sends to the server somehow this method that this insert should happen. But then how does it do it? So the thing is that it's using the DDP protocol. Again, if you don't know this name, DDP is distributed data protocol. It's basically some very simple protocol invented by, or like invented for Meteor, let's say. And most importantly, this is actually the part that actually makes the whole reactivity work. So that's how the client communicates with the server. That's how the documents are sent. That's how the data is synchronized. That's also how the methods are executed. So in this case, by default, we will stick to the default flow. So it will be using WebSockets, but it's like a secondary thing. There's also a very nice forum post about making it use different transports, but let's skip to the WebSockets just to make it simple. we send a message from the client to the server that we want to insert some document to the database. And now we get it on the server, and now we still didn't reach the database yet. So now we would like to go to the database itself, and we have to actually execute the actual insert, right? So we're using the MongoDB driver, which is like a JavaScript library, where we are actually doing the insert on the database. And this is using some internal MongoDB protocol. I guess you never had to, and I hope you never will have to, look into this protocol. It's actually pretty simple. It's been reworked like 5 times already, I think, if not more. But most importantly, that's an internal detail. We don't have to care about it. The server somehow, using the official SDK, using the official driver for MongoDB, sends it to the database, and the database acknowledges it, and we know that it was inserted. And at this point, the client still doesn't know that it happened, right? The server did the change, and even if we would introduce some sort of like confirmation that, hey, this succeeded, right? And actually we have it because the method will receive via DDP some confirmation that the method was successfully executed, the data will not be visible on the client. The document still is only in the database. There's nothing about it on the client side. So what the client side does to actually get the data is we subscribe for the data, right? We use the publish and subscribe methods of Meteor to have like the pub/sub model implemented. And after the subscription is started, we are not going to talk about it today. Somehow we have to get the data back from the database. So what we do is we are actually reading the oplog. And I wanted to use the dashed line in here to indicate that it's also going to happen asynchronously, because the insert is a synchronous operation. The server sends information to MongoDB. It's synchronous, like as in we receive the confirmation that it happened, not synchronous as in it doesn't require a wait. Like it's still an asynchronous operation because there's some network involved, but it's synchronous in a way that we get the response that the insert failed or succeeded immediately, or like as soon as it's finished. But then sometime later, MongoDB will push this entry that the insert happened into Oplog, and then the server has to tail the Oplog. So like listen to the latest changes, the latest entries in the Oplog. And once it gets those, it can actually notify the client that, hey, this document was added. So this is actually what happens, let's say, more or less in real time if your server and database are not very overloaded. So this whole round trip takes, basically 4 network loops, right? Because the client server, server database, database server, and server client. This is really a very low overhead thing for a single operation, obviously. And then if you would like to name all of the parts or like name all of the things that happen on every single of those arrows, in here on the client side, we also do something called a method simulation. What it means is that the method itself, the insert itself, can, for example, be forbidden because we don't have permissions for doing that. We, for example, have the allow deny package in Meteor, right? And it does make sense to check it on the client whether we are even allowed to do it, whether there will be like no error, maybe some validation will fail, things like that. So we can do it on the client, and then we get some sort of feedback even before we reach the server. But for example, the method failed or that it succeeded. We can then apply the optimistic UI. Again, we are not going to talk about it today, but basically optimistic UI is a way of making sure that on the client, we assume what the outcome will be even before we hear back from the server or even from the database for this case. So that's the entire engineering on the client side, how it works. It's a very big topic, a very broad topic. There are also like very different ways on how it actually can be implemented. There are also things to consider in here that, for example, we are optimistic on the client that it will succeed, but the server may fail for some reason, and we have to then unwind the changes. So a very broad topic. We are not going to jump into it very today. But then we also got the optimistic insert. So actually not only doing the optimistic UI for like results, but then we can also get the data available like in all of the places. So it's not like only the piece of code that actually executed the insert knows about the change, but actually the entire application just assumes that it's there, right? So the optimistic UI actually is slightly a bigger topic. It's not just like we assume that this one execution succeeded, but that the entire flow actually went through. Then on the server side, we have the actual method execution. So right now we are no longer simulating it, but now we are actually talking to the database. We are actually doing the validation. We are actually doing all of the, I don't know, access checks and all that stuff. And also, if we are fetching some data from like related collections, we are actually doing that against the actual database, right? So in that case, we are actually like truly executing the method, not only simulating it. And most importantly, in here, we also have something that is called an observe driver. And an observe driver is a piece of code that focuses on getting the data back from the database. And you can see in here that I added it on the insert arrow and not on the oplog. And that is because when we are doing an insert, we again have some sort of a mechanism where we can assume that, okay, because we are doing an insert, we can guess that the database will agree to it. The database will be happy about this change and will not deny it at some point. And we can already notify the listeners that, hey, this insert will happen soon, or that, let's say, we assume that it will happen soon. But then the actual observe driver does the heavy lifting in this part. So that means that in this case, the actual observe driver is the piece of code that actually launches the oplog query, that actually parses the oplog entries, and it actually notifies the Mergebox logic. Mergebox is a very funny, let's say, story, because I think the community somehow anonymously like agree that, okay, this is the Mergebox, but if you look into the code, there's basically nothing like that. There's not like a class or a function that is called Mergebox. It's like a collection of structures, a collection of classes, a collection of functions that operate as it. And I think that was like sort of like an internal name in some documentation, and it is still in some comments, but it's not like a single piece of code that is actually called the Mergebox. So that's why I put quoted codes in there. But most importantly, this is actually where we heard from the database that some operation happened, that the insert actually was executed on the database, that the insert actually happened on the collection. We are then analyzing this change, checking which piece of, like which connection, which client is actually interested in this change, and then actually generate those DDP messages and then push them to the WebSocket here. And what is really important for the entire purpose of this talk is that the oplog itself will process every single oplog entry that is in the database by default. We will get to the details later. But what it means is that if your database is really write heavy, your server has to listen to all of it and look at every single piece of change, whether it's interesting to it or not. Interesting as in whether any client would like to know and be notified about those changes, right? And that's exactly where the, let's say, performance penalty or like performance cost is actually coming from. Because if you are doing, let's say, only inserts from your clients to the database and then getting them back, that's trivial. That's not a lot of load, of course, up until some certain traffic on the client side. But then if you are, for example, having some front-end application with 5 users, but then in the meantime, you have a cron job or some API that just inserted 100,000 documents or did a migration that updated 1 million of documents at once, then every single instance of your application, every single instance of your server has to process every single one of them. And that's where the performance problems may happen, and actually happen a lot for a lot of clients, a lot of people using Meteor. And then on this arrow, so like getting back to the client, we have a mini Mongo. And mini Mongo is the actual piece of code on the client side that actually simulates how MongoDB actually behaves. That's why we can actually do inserts on the client side. That's why all of the queries that we can actually do on the backend work on the front end. That's actually where we are actually simulating the entire Mongo workflow, right? With counts, sorts, filters, projections, all sorts of things. And then also we have tracker, and tracker is the actual only reactive part in Meteor. So tracker is like, if you know observables, then tracker is basically some sort of like an observable. But most importantly, tracker is a very simple, like extremely simple piece of code. If you never saw it, you can just read it. Like the entire file is a couple of 100 lines long. I think if you exclude comments and exclude some helpers, it's like 100 lines. So like really not a lot of code. And it's also not clever, like not in a bad way, but like it's not like a very extremely complicated, a very extremely I don't know, convoluted piece of code. No, it's really straightforward. You can just read it and you can actually understand how it works, why it works, and why some limitations are arising, for example, when it comes to asynchronous operations. So I strongly recommend you checking out the tracker piece of code, also because it's one of the oldest ones, one of the least changed ones in Meteor, and also one of the heaviest ones on the documentation side. So like there's a lot of comments, a lot of explanation how it works and how it's supposed to work. So that's the default of Meteor. That's what actually happens when you just install a fresh Meteor application or just start with some starter project. That's how it all looks like. And now, what if we apply redis-oplog to this whole picture? So redis-oplog, if you don't know, is a community package that actually was created to make Meteor scale better. And the idea is pretty simple. We'll see it on a diagram right now. But then let's see how it all works. So on the client side, we still execute a method because we want to send the message. We want to insert some document to the database. But then the database is getting the insert, but we are also doing some other stuff in the background. We are also publishing the information the insert happened to our Redis instance. So in that case, server does slightly more work, right? Because instead of only pushing the data to the MongoDB, we are also sending some sort of a message to Redis that, hey, this insert happened. And obviously, this is using some internal Redis protocol. Again, we are not getting to dive into it. We are, again, using some official Redis drivers, some official, let's say, client-side SDK, like server-side SDK, sorry. And that's how we are informing everyone else that this publish happened, like this insert happened. And then we have to somehow get this information back. So what we do is we subscribe on the server to Redis. So in that case, we are no longer using the oplog. You can see that the arrow back is only coming back from Redis. There's no arrow back coming from MongoDB. And then we send the added to the client. So what it actually has to do, like the entire redis-oplog package, is about basically one thing. Because if you look at the arrows in here, the only thing that is, let's say, different, or like that would be different, would be the observe driver. And that's actually true. The redis-oplog is actually an implementation of a custom observe driver. An observe driver that actually uses Redis to publish those changes, like to multiplex as in notify multiple customers, like multiple clients that this change happened, but also subscribe from Redis instead of from the oplog. And that's actually important because that means that we are no longer obligated to listen to all of the changes that MongoDB is generating. So we are no longer, let's say, flooded with those changes coming back from those heavy inserts, those heavy bulk inserts, like cron jobs and all that stuff. But we are just listening to the things that our server published to Redis, right? So obviously, we have this Redis-based observe driver, and obviously, there is some overhead on the server because it has to do 2 network requests instead of once, just for every insert, right? So there's like slightly more load on the server, but this is really negligible, like because those published messages, like these are really trivial because we just send the name of the collection, ID of the document, and that's like a really small piece. So that's that. And then most importantly, we are processing only the published collections. So what I meant with that is that previously we were processing all of the oplog entries. So every single thing that actually happened on the database. And in here, we can just focus on the collections that not only we are inserting to, but also on the collections that anyone listens to. Because if we are publishing the name of the collection to the Redis, then we can subscribe only to the ones that anyone subscribes to. So that means that, let's say we have our database and we have some sort of like a CRM, like a customer relation management. So we have some customers, we have their addresses, we have maybe some profile information, that kind of data. And then on the side, we have, I don't know, maybe blog posts or maybe some heavy thing like webhooks or like some sort of logs, things like that. And this collection is never published to the customers. This is some database collection only that we are using for some internal tooling, maybe for the API, but we are never actually subscribing to it on the client side. So what it means that in this case, this solution will never actually listen to those changes from those collections, let alone it will never actually publish anything to Redis about those, right? So there's a huge performance gain because we are actually processing what is published there, and most importantly, we are only processing what is actually subscribed to. And this alone gives a lot of people like an immense performance boost. Most applications that I saw in real life, like let's say the bigger ones, were actually using it, not because they wanted to, but because they had to. And this is really going to give you like a long way. So like if you're not using it and you're having some problems with like Oplog spikes, so moments where your database receives a big chunk of like write operations at the same time, this is going to really buy you a lot of time to like investigate and improve the application over time. But then what actually happens if we have some sort of an external publisher? So an external publisher in redis-oplog methodology, or like, let's say, namology, is a piece of software that allows your server not to do any sort of like an additional work. So in this case, whenever we are sending the data to the server, again, using DDP, and then we are sending the data to the MongoDB, again, via MongoDB protocol, then we can have some additional piece of software, like in this case, changestream-to-redis. Like I'm the author of it. There's also Oplog-to-redis, which is using Oplog. This one is based on change streams. Technicality, but that's like a minor thing. I made this one, so I'll be happy about bragging about it. Then this piece of software is actually subscribing to MongoDB. So it's no longer our server listening to the MongoDB changes, but there's like an additional piece of software that actually subscribes to the MongoDB data and publishes it to Redis. And then our server still uses the default redis-oplog driver and just subscribes to the Redis changes and pushes them back to the client. So you can see that there's like one more moving piece in here, but most importantly, the server itself does less work, right? And that was our goal, that the server is actually less occupied, that the server actually has less processing to do. And in this case, because there's like an additional tool that subscribes to MongoDB using change streams, an important thing about change streams, like the only important one that you have to know for now, is that Oplog is an internal format. You can use it, and we are using it in Meteor heavily, but it's not documented. So when the Oplog format was changed in MongoDB 5, we basically had to reinvent the entire workflow there, but we did it, like it works. And change streams are, let's say, the official way for MongoDB to notify you about the changes. And most importantly, it's still based on Oplog. So like change streams are a way of accessing the Oplog in, let's say, a structured and documented way. So in this case, we are doing basically the entire flow as we did before, but with the small change that now someone else, like an external piece of software, is actually pushing the changes from MongoDB to Redis. I see there's like a question on the chat. In redis-oplog flow, isn't a confirmation of MongoDB insert needed before Redis publishes to Redis? I guess before server publishes to Redis. Yes, so in the workflow, before the server actually pushes anything to Redis, we have to wait for the insert to be finished. That's true. But I just didn't want to like add even more arrows in there because that would make the chart illegible. So in that place, in that flow, in this case that we have right now on the screen, there's zero overhead from Redis inserts because none of them actually happen on the server, right? The server just pushes something to the MongoDB, and then magically, this data appears in Redis and we are notified about it, right? Again, listening only to the ones that are subscribed. So we still are getting this benefit of getting notified only about the changes that are interesting to us. But there is some cost, that there is some additional latency. Because previously, we had 3 pieces, right? We had like server, MongoDB, and Redis, and now we have 4 of them. There's also like this changestream-to-redis or Oplog-to-redis deployed separately. This is not a problem, let's say, per se, because previously we were just like talking to like the number of arrows was more or less the same. But this may be a problem if those things are deployed in different areas. So it may be just like things to consider. But like from our experiments, it's, let's say, like 4 to 6 milliseconds. So that's, I think, negligible for most applications out there. And looking at this diagram, we can see that there is a single piece of software that actually does one thing, let's say, on its own synchronously, and that is actually publishing the results to Redis. But then all of the operations coming back and forth, so like subscribing from MongoDB and actually pushing from Redis to server, those are happening asynchronously, right? Because those are those dashed lines. They happen as they go. So now the idea would be that we can actually get rid of some of the arrows and kind of like mitigate the logic here, like mitigate some of the overhead. And that's basically the idea of DDP Router. So we can have the client, but right now we are not going to talk to the server itself. We're going to talk to the DDP Router. But as the DDP Router name says, it's actually based on DDP. So we can still communicate using the same protocol. Most importantly, the client doesn't have to know that it's talking to a DDP router and not a Meteor server, because that's still the same API, that's still the same workflow. Then the DDP router actually executes the methods on the server. And that's important in here because this is actually still your piece of code. DDP router is just a router yet. Like it doesn't do, like on the image yet, it doesn't do a lot. But most importantly, this is still your server executing the same piece of code that you had before. So there's no need to, for example, rewrite your application in a different language. There's no need to rewrite your application in a different format, in a different framework. No, it's still your application, still getting method execution via DDP. So that's still the same application that you had before with some party in between the server and the client. But it's the server doing the insert to MongoDB, as it was before, but then it's the DDP router that actually subscribes to MongoDB and pushes the data back to the client. So in this context, we have one more thing in the middle, like one more piece of software in the middle that is actually there. But what is important is that even if it would be using the Oplog, it's no longer your server handling the load. So what it means is that we actually extracted the entire logic of listening and parsing the database operations and publishing them actually to the client. So like those webhook connection, WebSocket connections, opening them, handling them, pushing data back and forth, filtering. We can actually do authorization in there if needed, going through those Oplog entries, but actually we are not doing Oplog there. We are going with change streams. Again, it's more documented. It's, I think, the only way forward with MongoDB. We can just expect them to kind of cancel Oplog in the next version or like a couple of versions ahead. And in this case, your server, so like the server that you actually have right now, is doing very little load at all. Like it just gets the method executed, which is, as you know, I don't know, 20, 50, maybe 100 lines of JavaScript code. And most of this code is actually oriented about inserting data into the database or like getting data from the database, right? But the actual heavy lifting of real time, the actual heavy lifting of getting the data back from the database to the client is done externally. And why is it actually better? Like, why does it even make sense? It's because this is a single piece of software that only focuses on that. So like, there's no business logic in there. There's no like additional thing that you actually have to code in there. So we can just produce a very highly optimized sidecar application, you can call it, that does only that. And currently it's like written in Rust, only because I have experience with Rust. And most importantly, this is like really highly optimized just for getting the data back from MongoDB to the client using train streams on the backend, but also pushing the data back via DDP. So in this case, it's basically an observed driver extracted into a dedicated server, right? So the server can still handle the load as was before. So like you can still connect to the server directly, like nothing is stopping you from doing that. But then you can just connect via this proxy that actually does the heavy lifting if you want to. And this is actually even less latency than before, because on the one hand, we have one, let's say, piece of moving infrastructure less than we had with the Oplog to Redis plus some external publisher. But also there's less latency because we can have multiple DDP routers deployed closer to the customers and then talking to the server via, let's say, the long leg of the network traffic, right? So then the communication with the client is like shorter and faster, because then the server can be communicated later. This is also like, there are also like other benefits. You can also read it in the repository of the DDP Router itself. I highly recommend it. But yeah, I think that's really an interesting approach to this whole solution. And then again, I'm also like the person who actually invented it and also built it. So I may be, let's say a little bit too optimistic about it, but I really think that's a very nice direction to go through to, even if it's not going to be this exact solution, but like this type of solution where the observed driver, so like the actual real-time communication with the database, is extracted from the server. So we can actually have a very small number of server instances with like small amount of resources, like not a lot of RAM, not a lot of CPU, because it's basically a very small, trivial, actually, API server that just takes some information from the client side and pushes them to the MongoDB, and then everything else happens externally. So now we would like to make some sort of a comparison between those three. So first of all, whenever we are processing only the published collections, with Oplog, I said it's processing everything, but it's not necessarily true, because there are two options called Oplog excluded collections and Oplog included collections, where you can actually manually specify which collections are processed or like which collections are not processed. And it works. It's been added, I think, a year or two back. But in this case, you have to actually manually, within your application config, define which collections are and aren't published at all. So it can still be the case that you are processing some events from collections that can be published, but are not necessarily published at this moment, right? So there can be still some overhead that is not needed. And then obviously on redis-oplog and DDP Router, we are only processing whatever is published, because otherwise we are not even setting up the listeners either to Redis or to MongoDB via chain streams directly. Then, what about processing only the published documents? So what if you would like to not only process whatever collection is needed, but only whatever document, like on a document level, is needed. So like a much higher granularity. So with Oplog, this is not possible. Like there's just no way to only subscribe to those changes, because it actually makes a lot of problems, and we actually have an example on the next slide. With redis-oplog, this is technically possible, and this is actually an interesting thing. I wrote an article about it. So basically the idea is that there are some custom channels on redis-oplog where you can publish documents by, I don't know, you can have, for example, some namespace that on this Redis channel, we're only going to publish documents that are connected to, let's say, a single tenant of your application, or a single document, or maybe a single publication that only relates to the people using dashboard, things like that. And then the idea in here is that because we have this external service that is actually able to connect to the database, it can help you to do it automatically. So it can, for example, handle the multi-tenancy publications just like automatically, like on its own. You just configure which collections have like this tenant ID field, and it just works. In our case, in Alino, it reduced the amount of database, like the Oplog notifications, or like, let's say, Oplog-like notifications in redis-oplog by 99.95%. So like we got down from like hundreds of millions to less than 1 million, which is a great result, honestly. And then on DDP Router, this is, again, not possible, at least not now, but then technically it could be doable within the same approach, just like the redis-oplog with changestream-to-redis is actually doing it. So this is technically doable, but it's not implemented now. But then there's one more thing, and that's about refetching full documents way more often than you would think. And all three are suspects here. And that's actually the problem. And in this case, I guess you may be wondering why I'm talking about and why there's like a fire emoji here. And that's because this is a problem. And that's a problem that basically no one talks about, because there's no way around it, and why we're going to see on the next slide. But I see there's a question. The main problem we face with using redis-oplog, it doesn't use the query params. Yeah, so the thing is that it can't really, like there's no way to do it. Also, the next slide will be kind of like an explanation why this is a problem. But if you are able to specify a single field of the query that is actually not going to be changing, like the tenant ID or user ID or whatever filter that is constant per subscription for your needs, you can just do that with changestream-to-redis. So go ahead, there's like a forum post, about it, there's my article about it, you can just check it out. If needed, you can also reach out to me for some help about that. So it was all a lie, like not necessarily everything, but there was a very important thing missing on those slides. So all of those diagrams were missing one crucial operation, and that is fetching data from MongoDB. Because as you heard me talking about those things, I said that the server does the insert, then gets acknowledged that the insert succeeded, and then we are getting the data back either from Oplog or via chain streams. In both cases, it just worked, right? But both solutions actually have a problem that some operations need to fetch the data, like a full refetch of the query. And there's like many more of them than you would think. There can be mitigated in redis-oplog using some flag that is called protect against race conditions. And then you would actually have to have an external publisher with pushing the entire documents there. It's possible. It gives you even more performance boost, but it comes as a cost that you actually have to process large documents multiple times. So go check it out. Go check out the documentation. It's possible to do it. But now let's see why we can't really do better, because that's actually a huge deal breaker, why it just can't be done better. So let's say that we are having this kind of data being published to the customers. We're publishing top 3 users according to their score, some sort of like a leaderboard, or maybe some sort of like latest users, things like that. You can imagine a similar case in your applications, I can believe. And what we actually are publishing in the first case, so like we are going to the database, we are executing the actual full query, and those are the results we got. User X with score 42, user Y with score 37, and user Z with score 21. Okay, that's great. So now we have 2 scenarios. First scenario is that the user should be added to the results set. That's because, for example, there's user A with score 69, so that's on the top of our list. So when we are notified that this user was inserted, so like this user was created, then it's all good. We just push it on the top. We know that it's the first customer, like the first user, sorry. We should publish this user to the clients, and then tell them that the user Z should be removed from the results set, right? Because user A is in there, and we are only publishing first 3, so then user Z has to be removed. But there's a separate scenario. And in this scenario, some users will be removed from the results set. So we say, okay, now user X, I don't know, lost in some game. And their score right now is 1. So it's a problem because we know that they have to go down on the list. But we also know that they have to go potentially to some more distant position than the third one. So we know that user Y is going to be the first. We know that user Z is going to be the second, but we have no idea who may be there on the position number 3. And in that case, we have to execute the actual full query on the database. We actually have to refetch the entire data set, refresh the entire result set, and then see, because maybe, just maybe, user X is actually going to be the third one, because there's no one else between user Z and then user X with the new score, right? But we can't really do better than actually getting the entire data back from the database using a full refetch. Now, we could, technically, what you can do is, let's say we have limit 3 in here. What we can do is we can say, okay, if there's limit 3, we will actually store top 6. So like twice as much documents. Okay, that's a solution. It's also going to save us a lot of refetches if we know that those refetches are going to happen within this, let's say, doubled buffer. And that's exactly what Meteor does. I guess not a lot of people actually know about it, but if you're using limit, then that's actually what Meteor does. So like Meteor actually keeps like double of your limit, or like double -1, I think, something like that. So that's how it actually achieves some, let's say, latency reduction. So like some refreshes are skipped at the cost of storing more documents in memory, right? So like there's some drawback, there's some improvement. There's a similar problem with skip, obviously. Like with skip, we have the same problem, but with skip, we are just knowing which documents not to publish. and then the documents that are actually published. So it's also doable, but then we really can't do better, because if we have like 1 million of users and then they have like very, I don't know, their scores are very dense, so like they go one after the other, then we really can't do better. Like we have to refresh the entire data set, or at least say that we want to skip the first two because we know which ones are the top two, and we just want to fetch the third one. That's also doable, but at the same time, we can just refresh the entire thing, because that's still an actual query that we have to execute and still have to wait for the network, and it's just easier just to refresh the entire thing. So the takeaways from this entire talk that I want to, let's say, stay in your heads, at least for a while, is that Meteor reactivity is basically a lot of things just tied together to make the magic happen. There's no like Mergebox that actually makes it work. There's no like, I don't know, mini Mongo does this. Yeah, like all of those things are very clever. All of those things are very well engineered. All of those things are battle tested for years by like thousands of projects used in the wild. But most importantly, it's just a lot of pieces connected together. And why is that important? Is that A, you can always dive into them. You can understand their code. You can make them better. You can replace them if you want to. And the redis-oplog is doing exactly that, right? So they just took this one piece, the observe driver, and implemented another one using Redis. What is important in here is that also there is an ongoing process right now in Meteor Core. I guess some of you actually may know about it. There's a pull request that is actually being worked on for quite a while to actually implement a chain stream-based observe driver. So kind of like, let's say, bringing DDP Router inside of Meteor Core, right? So that's basically the idea in there. So yeah, I saw that Jan just sent a link to it. I think that's this actually pull request. So it can be done, but then it's still our server processing the same kind of data, the same kind of load, right? Of course, we no longer need Redis on the side. We are no longer processing all of the Oplog entries, but it's still like, some change that your server actually has to process. And I'm personally in favor of either using, for example, the changestream-to-redis as a sidecar, or even the entire DDP router as a sidecar, because then this logic is like extracted into a dedicated service and it can be scaled independently and so on and so forth. Then my recommendation, like let's say the approach that I suggest whenever I'm doing some consulting, or that I did consulting in the past and I'm doing consulting right now, just start with Meteor default. Like, don't think about it. Just launch Meteor as it is, see how it works for you. Maybe it will be just fine. Of course, if you can do something not in real time, consider it. But if you need real time necessarily for any reason, including business ones, just use it. Just use Meteor as it is designed, as it's built, and just see how it works. If it works for you, then that's great. You don't have to spend any more time on anything. But don't, then just try installing redis-oplog. There's obviously some additional cost that you actually have to host the Redis instance, but we are really talking about a $5 a month instance of Redis, and it's not going to be overflooded by the load anytime soon. Like in our production setting, our Redis is, I think, configured to have like 500 megabytes of RAM and 0.1 CPU or something. So that's basically nothing compared to the entire application, and it does really well. And we are actually using it also for caching. So there's like much more load on it than just the redis-oplog messages. Then the next step, if you are still having some troubles, I would consider changestream-to-redis, again, at some cost of additional piece of software that you actually have to deploy and host. But here we are talking about less than 0.1 CPU and less than, 100 megabytes of RAM. So that's, again, still nothing. You can just put it somewhere. You can have it hosted for like multiple instances, for example, your test environments, your staging environments, and still be happy about the entire solution. There are some upsides to it other than the performance, and that's, for example, not having to publish all of the entries from Meteor. That's not only a performance improvement, but that's also an improvement where, for example, some other services are, let's say, talking to your database directly. For example, you are having some cron jobs that are executed on your MongoDB instance, then you don't have to care about publishing those entries from MongoDB to Redis, because that's exactly what the changestream-to-redis is actually doing. And The third point would be that the DDP router is not really actively worked on right now. And that is because it was implemented as a, let's say, proof of concept over a year ago, and it was published sometime later. And yeah, the people that actually were beta testers of it found some problems, but we really couldn't really pinpoint them any further because they didn't really want to spend that much time helping to build this tool. And I fully understand it. I really appreciate the work that they actually did. But at the same time, we really couldn't access their code bases to check it even further because that's like proprietary private databases. But what we do know is that it worked well, for example, for Atmosphere, so like the Meteor package hosting. It's not being used in there right now, but it actually helped Atmosphere to like reduce the, I think now the CPU load by like 20 or 30% and the RAM by roughly a half, right? So I really believe that this is like a really viable and like one of the very few viable approaches for the future of Meteor, because even if we would bring the chain streams to Meteor core, we still have to scale it further to actually handle the publications. And with using like external software, then our servers can stay very slim, very small, and then we can have like dedicated tools to only handle the real-time part, the real-time publications. And that would be it from my end. Now there's like time for questions. That's the QR code for Roti, and that's also going to be some time for questions on the chat. So if you have any, feel free to shoot them right now, or after the recording is finished, if it's actually a problem for you. And yeah, that would be for me.
All right, thank you very much for the amazing talk. I think there was one.
Yeah, there is one from Nikita.
Yes.
What to do where we process thousands of Redis messages with changes, and each message is sent to the client, causing the front-end render transport issues, and there is no any chunking or other optimizations? Yes, I agree. So first of all, there was an idea of DDP batching, and this pull request is revived once in a couple of months or like once every couple of years, and it's dying every single time, unfortunately. But I would say that, first of all, there are some tweaks on the server. I don't remember their names now, but you can, for example, change the number of messages being buffered on the server when it comes to DDP. So that's one part, and that may help you a little bit. And then on the front end, you can also do kind of a similar thing. So kind of like a throttling on the front end that you have, for example, some tracker auto run, and that's, let's say, good enough to fetch some data and then push them somewhere, whether it's like a tracker auto run directly, whether it's like a Blaze auto run or like use tracker in React, doesn't really matter. But you can just push those results not directly from this tracker to your component, but you can get those results into some reactive var, for example, and then batch those changes. So for example, refresh them not more often than once in a while. So basically like a debounce used in tracker. We are doing that at Alino. We are doing that because our application is mostly real-time. Our application is like, I would say 90% of data is real-time because that's our business and that's how it has to operate. But yeah, we are doing that only whenever needed, and it's not needed that often. So give it a try. Maybe it will work for you. But if not, yeah, I don't see any other options, at least not now. Is the implementation of chain streams for Meteor 3.5 the same that is already implemented in DDP Router? How much better in average should be chain stream versus Oplog? That's an interesting question. So first of all, the implementation that is done there, yeah, off the record, but I'm literally being recorded right now. It has some downsides. Like, it's not ideal, I would say. There were some concerns raised from the community, but it's worked on right now, and I guess there will be like some review process later when it's ready, because right now it's not really ready. But at the same time, the thing is that the one in DDP Router is completely different for two reasons. One, because the one in DDP Router is just the part from the database to the client. There's no this observer driver when it comes to pushing things to the database. So it's, let's say, smaller, simpler, but at the same time, it's like more opinionated when it comes to that. And also, it's different because it's a different piece of technology. Because Meteor is written in JavaScript, DDP Router is written in Rust, and there's like a lot of complexity coming from the part that DDP Router wants to be able to use multiple processes. So there's like a lot of synchronization of the data, synchronization of like multiplexing against multiple threads. So it's different in terms of like implementation, but from like a chain stream perspective, it's kind of the same. So like, let's say the same chain streams are executed against the database. That's like the idea. And how much better in average it should be. There is a discussion on GitHub that I also started some time ago, a couple of years actually ago, and there are some measurements from my end. So the thing is that on the database level, it should be like no different at all. Like the amount of, let's say, the level of load that Oplog tailing and chain streams are pushing on your database, that's basically the same. And that's because the chain streams are just like, as I said, like kind of like an access API to the Oplog itself. But when it comes to your application, they will be better on average, I would say. But how exactly and whether there may be no regressions, it really depends on how actually you are accessing your data. And that is because Oplog is better in some context and chain streams are better in some context. So for example, if you are updating a lot of arrays, Oplog may be better. But if you are having, for example, multiple nested objects, then chain streams are handling that better. So it really depends on the type of data. And that's not, let's say, a problem of the implementation itself, but that's a problem of how this data, like those changes, those differences are represented in the protocol, right? And because Oplog and chain streams are completely different, there may be some differences either for the upside or for the downside. There's also like another case, and that is the question of scalability of it. And that is, you can have chain streams to be more precise, to be more filtering out the data that you are interested in, but then you may need to have more chain streams in general. And there is some limit that actually your database poses to the maximum number of chain streams or like connections you can actually open. And on the one hand, your database will deal with like 20,000, 50,000 or something. That's not really a problem, but your server won't. So it means that your server will do less work, but there can be more congestion, like more latency that is there only because your data is being processed, let's say, by multiple chain streams in parallel. So instead of having like one flow of like big chunks of information, you have like a lot of very small flows, right? A lot of very small streams. So overall, I would say that on average, it's going to be better, but at the same time, there may be cases where it may be worse, also depending on the implementation. I know it's not really a very hopeful answer, but yeah, that's the one I have.
Okay, I think there are more questions incoming, so let's give it a little bit more of a time. I'll just also add that right now, change streams, from what I've gathered, are scheduled for Meteor 3.5. So that's so after 3.4 is kind of done. That's where we'll see the biggest push forward. So
Okay, cool. I don't know what type of app benefited from DDP Router the most. So for us, the thing is that we are actually having a lot of real-time data. Like, as I said, like 90% of data. We don't have, let's say, a lot of active users connected to the app at the same time, not like when you look to the entire scale of the application. But in our case, the thing is that there is not a lot of users, but there is a lot of data. So this is kind of like a back office application. So we have GraphQL API, we have REST API, we have a lot of integrations that are synchronizing like thousands of requests every minute, like tens of thousands of requests every minute. And all of those are actually pushing data to our MongoDB. And then this data is published to clients in real time, because that's basically a restaurant, like system for restaurants, and they need data in real time. Because if you come to the restaurant and you're standing at the door, they want to know if this table is available right now or if someone just booked it, right? So real time is actually very important in there. And in our case, we saw a massive memory reduction, some reduction on the CPU, but the reduction on the CPU was there mostly, like, it wasn't as significant, but it was mostly because most of our CPU load is coming from the APIs and not from the DDP and publishing the data. So yeah, cutting down RAM is great, because then we can actually get down from like, I don't know, 30 instances to 10. But then, yeah, it again depends on the application. From Valerie, is Meteor reactive system a good choice for high-load reactive app or just something smaller? So I can't give names, but I was actually auditing and like consulting a couple of applications. Even one was in Fortune 500, I think, and they had like tens of thousands of users active, and there was quite a lot of reactive data in there, and it worked. Like, okay, they had a lot of servers. Their MongoDB was, I think, M200 or something, because they had a lot of data and they actually needed this kind of database. They had like more than 50 instances of the application with like 8 gigabytes each, and it worked, right? And at their scale, this was still peanuts. Like, it was still cheap to host this kind of application, right? It was still beneficial for them. So I don't think there's like any limit to Meteor itself, but just at some point you have to actually start thinking about whether you can actually make it cheaper, right? Because you can always throw more servers. Like, even if you would have an application with like 1 million of users, if you would have 1 million of instances, it just works, right? There's nothing to worry about. But then that's not the goal, right? We want to really reduce the cost as much as possible. And then there's just that. At the same time, I personally don't know of any framework or like other solution that would allow you for such a level of reactivity and not come with any performance problems. There's, for example, Phoenix, written and like used in Erlang/Elixir, and it's also very nice, but it also like at some point has to like get more resources to actually do the heavy lifting of real-time communication. Jan, what is not a lot of users to you? So I won't give you a number, but I can tell you that, for example, our DDP is at, let's say, 2,000 method executions per minute, and our API is at 10 times more than that, right? So not a lot of users, not like overall, but like not a lot of users compared to the overall load on the application.
Okay, we'll close it up here. I think one thing I would like to add here, kind of to the previous question, I think it really doesn't matter what you are using. Once you get into the area of scaling, any system will require, or any app will require, reworks, more resources, and rethinking. Oftentimes, just matter, does the system make it easier for you, or when does that time come, and how can you then expand from that?
Yeah, so I can just maybe this will be like a very positive thing to end the discussion with. So with redis-oplog, you can just have one single Redis instance, potentially changestream-to-redis also deployed nearby to it, and then you can add as many instances as you need of your server application, and it works. Like, I never saw a problem with redis-oplog with getting too many things on the Redis side. So it's not like it's going to scale like linearly, but it gives you much more runway for your application. So you have like more time to prepare for the load to come.
Awesome. Thank you very much. I'll just finish recording here.